So I'm going to go ahead and ask a question that came in for Kathy, and then we can kind of just transition directly to our discussion period. So someone asked, how high are the engine nozzles off the surface at landing? And there's a few other questions embedded in here. What's their approximate max thrust at launch? Does the landing sequence include shutting them off before touchdown?
Well, with some of them, yes. I mean, with 8, we can use we can throttle. Our throttling strategy involves shutting down some of the engines as you get down. And once you get to the surface, they're probably at least 2-3 meters above the surface of the moon. So the final design in those areas is still, we're still in the preliminary design phase, but that's roughly what you'll see.
Okay, great, thanks. All right, so I guess we can kind of try to navigate through some of the questions that are remaining in the Q&A that we didn't get to, or if anyone wants to chime in with a question for a speaker, feel free. Addie, feel free to jump in as well. I'm kind of scrolling through to see what we didn't get to.
Yeah, I know there were a couple of questions early on during some of the talks about electrostatics, different surface forces, and there will be some talks this afternoon about it, both in terms of what we know and some instrument ideas. And that is true for some folks that ask about things like composition of regolith. And so there will be some talks this afternoon that will cover some of that a little bit more as well. And by this afternoon, I mean after now, so whatever time that is for you.
There was a question from Dean Epler that I thought would be worth asking, and this might be, I think this might have been for the STMD folks, I'm not sure, but if anyone here can answer it, feel free. He asked that we have less than 4 years to bring investments to TRL-9 and incorporate them into design and fly them, and the question basically was how are you going to do this? I guess maybe Michael did kind of answer this, I just saw.
That's okay. I can.
If you want to answer it in more detail, that'd be great. Yeah.
Yeah, sure, no problem. It's a fair question, but not all the technologies need to be ready by 2024. So first, for the earlier missions, what you'll see is a very heavy operations and architecture focus on dust mitigation approaches with a few technologies. And then as time goes on, you'll see more of these advanced technologies be integrated into lunar exploration.
Great, thanks.
Hey, Ryan, this is Jack. Can you hear me?
Yes, I can hear you, Jack.
I remain very curious of why the idea of developing covers for the XEMU and other, shall we say, fabric-like materials that reject dust. Has this not been investigated? I thought there had been off and on significant investigation of rejecting dust off the EMU, and if you can do it off of that, you can reject it off of other things as well. I hear crickets.
So do you mean in terms of having sort of like dust rejection methods versus dust mitigation methods? This is actually something that I think will be good to talk about during the breakout session. Is like,
right.
What is dust rejection versus dust mitigation, or dust keep out and exclusion versus dust mitigation?
It seems to me the most cost-effective way to deal with dust is not a whole bunch of mitigation methods. It's rejection. It's never bring it into the cabin. And never let it get into areas where it's going to be a problem. Why don't we invest our resources, limited as they are, in rejection rather than in all these different techniques for mitigation?
So I do wish that that Amy was on right now because she had a few things in her slides about the spacesuits, and we do have her slides. I think they're just next in this packet, Amanda. If you want to go ahead a couple slides, there's a slide maybe 4 or 5 in of the spacesuit.
This is Ron. Can you hear me? Hey, Jack, I say amen.
To say, yeah, you're preaching to Ron's.
Well, yeah, and Ron's very familiar with the LRV, and basically it was a rejection system, and it worked extremely well, except for commanders that tend to break fenders off, and we repaired that. It didn't take much of an effort, really, frankly, to repair it, thanks to the team in Mission Control. Terry Neal and obviously John Young was involved, but Terry Neal came up with the basic fix based on what we had in the cabin. But again, I remember being down at KSC probably a decade ago or more, where they were showing a solar array and radiator surface rejection techniques. What's happened to all that?
For some of those hard surfaces, and I think Michael mentioned this briefly, there is some work from folks still for the EDS, so like the electrodynamic dust shield, ways to remove dust from harder surfaces. I don't know if Michael wants to mention anything with that at all.
Sure. Yeah. So that technology that you saw at KSC is called the electrodynamic dust shield. It's currently it's just coming back. It's being tested on the International Space Station for space environments on the MISSI platform. There's also an opportunity to demonstrate this technology on a CLIPS mission in the future. So that technology that you've seen is certainly going to be part of the larger dust mitigation, dust prevention strategy.
And I
well,
think
you may understand my frustration, because Cernan and I really did lose a lot of time trying to mitigate dust, and it would have been much better for exploration, for operations, and everything else if surfaces and fabrics and everything rejected that dust. That should have been our emphasis for the last 50 years, but it hasn't been.
Yeah, and in addition to the active techniques, there are folks who have been working on like surface coatings and things like that are passive ways to make dust not stick to things. One of the questions Laurent Sabile asked in the chat is, were there observations about whether dust keeps accumulating on hardware on the surface, or does it only accumulate to a thin layer and then no additional layers? So like, does it adhere to itself? And I think the quick question to that is yes. But I don't know if Harrison, it says, or if
it keeps accumulating. There's no question about that, and it just it's one thing to be manipulating dust covers, and we did, but it would be much better if the dust just never accumulated. And I find it hard to believe that good engineering and good engineers can't come up with solutions fairly quickly on doing that. We obviously have had 50 years to work the problem, and it hasn't happened. So I understand about funding constraints and things like that. But the XEMU briefing I had, it appeared that that NASA was expecting to use Apollo techniques to get rid of dust off the XEMU. And I just find that very, very surprising.
I don't have an answer, but that's a great. We'll definitely have that in our report out. And I know that I'm sure you're talking with some other folks about it too. There was a question from Kirby Runyon, said, is there a role for water to remove dust from suits? Maybe picturing like a hose to spray everybody down. Or he says spray inside the airlock, moist cloths, etc. I'm not as sure if folks are working on that. And then Jeff Gillis-Davis had asked about using hard-sided suits instead of soft-sided suits for these kinds of things. Let's see. Trying to look back to some questions from earlier this morning as well.
While you're doing that, Ryan, I might just mention one thing and maybe ask a question about the retroreflectors. I'm unaware of any published information. It doesn't mean it doesn't exist, that the retroreflectors have degraded. And I would not immediately assume if they have that was because of dust. This idea of dust levitation really is not supported by the observations that I made and others have made on the surface. Rock surfaces are not covered with dust. And you would expect them to be if you were getting levitation and motion in that levitation that would somehow degrade a retroreflector. So I think that's something you need to think very seriously about. And Laddie, of course, did not see any sign of dust levitation.
Yeah, so we'll have Mihai Harani on in a little bit to talk a little bit about the Laddie observations. In respect to the retroreflectors, there's a really interesting paper by, I'm completely blanking on the first author right now, but he is at New Mexico, and so he uses the ranging from the laser ranging to look at the retroreflectors, and they do see a change in signal that I believe they looked at it in eclipse and not in eclipse, and they saw a difference in signal that they attributed due to thermal effects that were likely due to dust on the surface of the retroreflectors. So there have been changes over time. I'll try to find the reference for that and post it in the chat.
That may be how it's been interpreted, but that lunar environment is very hostile for a bunch of other reasons. And there may be other ways in which the shape of the retroreflectors, the shape of the cubes, can be distorted besides having dust come into them. If you come up with that reference, just email it to me. I'd like to see it.
Sure, will do. And there's been a lot of experimental work and also some modeling work. And I think Xu Wang just posted it in the chat that there's this recent Chang'e 3 rover observations of dust deposits on the sides of rocks and on the tops of rocks up to 28 centimeters in height. So they have some sort of like ground level observation. I think that the big question about dust levitation, and so I've studied this a decent amount. So one of the big questions about dust levitation is like the timescales over which it happens and under what sort of lighting and plasma conditions. And so we expect that and a lot of it's thought to happen a little bit more at the terminator regions where you have stronger and different electric fields, and why you might get really interesting conditions at the polar regions where the plasma conditions are a little bit different. Oh yeah, Clive just posted the paper. It's Tom Murphy in the chat, but we can also send that to you. And then I think that maybe
there's
sorry,
debris.
Go ahead,
There's regolith debris on rocks. There's fillets. The rocks are being eroded by micrometeor impact as well as by solar particle spallation. But if you're getting levitation a couple times a month, and it's moving, then you would expect to see that fine levitated dust accumulating on rock surfaces. And I'm unaware of any evidence that has happened. Certainly observational evidence says it hasn't happened.
Yes, it's it's a challenging and an interesting open question, I think.
Well, it's not. One thing, as a geologist observing the surfaces of rocks and identifying minerals and other things on them, I would say there's no dust cover on those rocks, okay?
All right. There have been a couple of interesting papers about this dust levitation and dust movement problem that have come out recently as well. But I think there's somebody online. I'm going to slightly change the subject real quick before we go into our break. I think there's somebody online, Brian Troutman, who might be able to answer one of the questions about spacesuits that we had earlier.
Right, yes. So I'm a systems engineer for the PCS, the pressure garment system for XCMU. So to answer Dr. Schmidt's question, we have a system in place as the EPG, and that is an outer garment that is intended to go over the suit. And one of the intents is to have that be at the initial outer layer to help protect against lunar dust and regolith that may collect on the suit. So that's something that's a subsystem, so to speak, that's in development. That's part of the PGS system.
Will that be disposed of before entering the habitat or the cabin?
My understanding is that that's not meant to be disposed of, but I can double check that.
Well, then it's going to bring dust into the cabin.
Right. And so the approach that we've been looking at is trying to select materials that are going to be ideal to repel that lunar dust and prevent as much embedding of the particles into the textile or into the material as much as possible. And then we're hoping that along with cleaning activities that will help to mitigate the introduction of dust into HLS. That's the approach as it currently stands.
Well, of course, what I'm trying to get away from is any kind of cleaning activities. That is a waste of time.
That point is well taken, and I can definitely take that back to Amy.
All right, great. Well, lots of good discussion, and there's a lot more questions that are kind of cropping up in the chat and the Q&A. So if anyone wants to tackle those, feel free. But right now, we're going to move into a 25-minute break.